Dear listeners, my present discussion is on Rutherford scattering. First we see scattering angle. Rutherford allowed a beam of alpha particles to fall on a gold foil. This is the gold foil. He observed that a greater part of the alpha particles pass the foil undeviated. A small part were scattered in different directions. Some were scattered at large angles. Here you see 4 alpha particles are falling on a gold foil kept perpendicularly with the incident direction. They are scattered in different directions. The distance of the nucleus from the line of incidence is called the impact parameter. It is denoted by B. Here we see for the first alpha particle B is 0. For the second alpha particle B equal to X. This is B. For the second alpha particle B equal to third alpha particle B equal to 2X. And for the fourth alpha particle B equal to 3X. The angle between the incident direction and the scattered direction is called the angle of scattering. It is denoted by theta. Here in this figure, for the third alpha particle, the incident direction is here. This is the incident direction and this is the scattered direction. The scattered direction makes an angle with the incident direction theta. It is called angle of scattering. It is large when B is small. In figure 2, you see an alpha particle with impact parameter B is approaching a gold nucleus and it is scattered through an angle theta. The initial momentum of the alpha particle is P1 vector and the final momentum of the alpha particle is P2 vector. The angle between these two momenta is theta, which is the angle of scattering. The collision between the alpha particle and the gold nucleus is an elastic collision. So, its kinetic energy and the momentum, magnitude of the momentum will not be changed. That is, the modulus of P1 equal to the modulus of P2 equal to mv. A triangle of P1, this is P1 and this is P2. The angle of P1 and P2 is drawn here, from which the change in momentum delta P is found out. Delta P acts along a direction which bisects the angle pi minus theta. This is pi minus theta. Delta P bisects this angle. This is the direction of delta P. Direction of delta P. In the triangle, the first angle is theta and the second angle is half pi minus theta. According to the law of sines, delta p divided by sine theta, delta p, this is delta p divided by opposite angle theta, delta p by sine theta, equal to mv, modulus of p2 is mv, mv divided by sine half pi minus theta, that is pi minus pi by 2 minus theta by 2, which is equal to mv divided by cos theta by 2. Or delta p divided by 2 sin theta by 2 cos theta by 2 equal to mv divided by cos theta by 2. So it is delta p. So delta p equal to twice mv sin theta by 2. The repulsive force F makes an angle phi with the change in momentum delta p. Then we may write delta p equal to integration f cos phi into dt, limit minus infinity to plus infinity, that is time limit is minus infinity to plus infinity. As we know, change in momentum equal to force into time. Here, summation of the component of the force along delta p into time is the total change in momentum delta p. We have already seen delta p equal to twice mv cos twice mv sin theta by 2. Sin theta by 2. This is equal to integration minus infinity to plus infinity f cos phi dt. This can be written as dt by d phi into d phi. The torque on the alpha particle tau equal to r cross f. As the force F acts along the position vector of the alpha particle, that is along r, therefore torque on the alpha particle is 0. So the angular momentum of the alpha particle is constant. Thus, I omega, this is angular momentum, equal to mr square omega equal to mr square omega equal to d phi by dt equal to momentum mv into b. Therefore, d phi by dt equal to vb by r square or dt by d phi equal to r by vb divided by r. it is r square. Therefore dt by d phi equal to r square by vb. Putting the value of dt by d phi in this equation, we have dt by d phi twice mv sin theta by 2 equal to integration minus infinity to plus infinity f cos phi r square by vb into d phi equal to integration half pi minus theta minus half pi minus theta to plus half pi minus theta f equal to 1 by 4 pi epsilon naught 2z square divided by r square. R square by vb cos phi d phi equal to 1 by 4 pi epsilon naught 2z square divided by vb integration cos phi d phi, that is sin phi limit minus half pi minus theta plus half pi minus theta which is equal to twice cos theta by 2, that is 1 by 4 pi epsilon naught 2z square by vb 2 cos theta by 2. Now twice mv sin theta by 2 equal to 1 by 4 pi epsilon naught 2z square divided by vb cos theta by 2 cos theta by 2 2 cos theta by 2 to cancel out. From this we can write cot theta by 2 equal to twice pi epsilon naught mv square divided by z square into b, which is equal to 4 pi epsilon naught Ek. Ek is the kinetic energy of the alpha particle, which is half mv square divided by z square into b, that is theta equal to 2 cot inverse 4 pi epsilon naught Ek divided by z square b. This is the scattering angle you have. Thank you.